SCL, right? Access control list.
Yes, sir.
All of you comfortable with the SL concept? Everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Okay. So standard and extended SCL, what's the difference? Difference between standard and extended SCL?
In standard, we will do the access list configuration onto the device which is closest to the destination. While in case of extended, we will do the configuration to the device that is closest to the source.
Okay. And apart from that, there is the configuration, right? Apart from that, what are the differences?
In standard, sir, both the servers are unreachable. In extended, we have to type the IP address for which we have to detect it unreachable.
It means what? Well,
Yes, sir.
it means what? This is the requirement, now. This is the requirement. When we have a requirement, we do a CL.
Yes.
So one more difference is in case of standard, the ACL, if you are considering the standard on the basis of number, there the range will be from between 1 to 99, and in case of extended, it will be from 100 to 199.
Okay. And apart from that, what more difference you have? Standard SCL matches traffic based on
Source IP address.
source IP address. Okay. And extended SCL matches traffic based on?
There are so many things comes into question: source, destination, protocol.
Source IP, destination IP,
Destination. So protocol also came into picture.
protocol information. Then
Yes, sir.
Number info, packet type.
packet type, all this. Okay, take the screenshot.
Done, sir.
Taken, right?
Yes, sir.
So, what exactly we have over here? This is your network address translation. Everyone remember the IP version 4 address?
Yes, sir.
Yes, sir.
Range, classes. All of you comfortable?
Yes, sir.
Yes.
Okay. Prajanan,
Yes, sir.
tell me the public address range.
Public address. It has 5 classes. Class A 1 to 126. Class B 128 to 191. 198 191. Class C 192 to 223. Class D 224 to 239, and class E 240 to 255.
42 to 55.
Yes.
And private range?
Private range 10.0.0.0 to 10.255.255.255. Class B 172.60.0.0 to 172.31.255.255, and Class C 192.168.0.0 to 192.168.255.255.
That's correct. So, public and private address difference, who can tell me?
Sir, public address, we can say this is routable on internet, and private address which is not routable on internet.
And
So public IP address is not free of cost. Private IP address is free of cost, and
Yes, sir.
public IP
Public-
address consists of 5 classes, and private IP address consists of 3 classes.
classes. that is
Yes, sir.
So with the public IP, we can access internet, right?
Yes, sir.
Yes, sir.
With the private IP, we cannot access internet.
Right.
Now, all our machines in our LAN, they're basically using private IPs all the time. Like when you create your LAN, you give private IP address to your machines. And with those private IP address, we are not allowed to access internet. Why? Because duplicacy of address, it may occur. When we are using private addresses, since these are free of cost addresses, other machines can also use the same address what exactly you have given to your machine. That is what exactly the possibility. And that is the reason these private addresses are not being used on internet, because this is subject to duplicacy. So if we are not using public address on our machine, then all these machines will not be able to access internet, right?
Yes, sir.
Then how come we can make communication on internet? If we consider this particular, all these three LANs as part of internet, then how come my machines from LAN 1 will communicate to any of the servers which is available in LAN number 4?
Yes, sir.
Are you getting the point?
Yes, sir. Got it.
Over here, we are using private addresses in LAN 1.
Yes, sir. Yes.
And let's consider LAN 2, 3, and 4 is part of internet. So when we are communicating from PC 0, PC 1, or laptop 1 to any of these LANs, since all these LANs are part of internet, these machines will not be able to access anything on this LAN 2, 3, and 4, because on the ISP, okay, on the ISP routers, we are considering this router as an ISP router, this router as an ISP router. So on the ISP routers, these addresses are not allowed. So when you send your packet to internet, this is when you are using a private IP, which is not allowed. So in this case, how come we can make communication to internet?
So then only our, oh, sorry.
Then with this particular IP address, without changing the private IP, how come we can make communication to internet? Basically, what I'm trying to say here is this, that by using a private IP, how you can still make your communication to internet or to the public network. So this particular problem is resolved using NAT. When you use NAT, that is your network address translation, your private IP is getting translated to a public IP. This is the translation which is basically performed by routers who are it is configured with this NAT concept. In the NAT, always private address gets translated to public address and public address gets translated to private address. By doing this translation, our machines can still use their private address while maintaining communication to internet. So the router where we configure this NAT is called NAT router. Okay. It's called NAT router. And we have to configure NAT technology in that particular router, which is on one side it is connected to private and another side it is connected to public, because we are considering this as our internet. This is what we are considering internet. So the router which is performing your NAT, this is called NAT router. And every single NAT router, it maintains a table. When you perform NAT on router, always that NAT router, it maintains a table, what we call NAT table. This table is maintained in this particular router. Now, in this NAT table, what exactly is there? This information, like which private IP is translated to which public IP is translated to which private IP. This is what exactly the translation. This is the translation, what exactly exists in this particular NAT table. So all this private IP, public IP, private IP translation is contained within this NAT table. The NAT router always looks after the NAT table in order to perform the translation, because when it receives a packet from any of these machines, like PC0, PC1, laptop 1, at the time it closely looks after the source address to perform the translation, because the source over here is intranet, that is your private network, because we are considering this particular section as intranet, and this section on the right side we are considering it as internet. Intranet, that is your private, and internet, which is your public. So there are certain terminologies. Are there in NAT which you need to know. Definition wise, this is what exactly definition of NAT looks like. It is used to translate your private address into public address and vice versa. Vice versa simply means public IP to private IP as well. Because we are having very limited number of IPv4 addresses, as our IPv4 address, it is just about 32 bits. So 2 raised to 32, whatever value is coming, that many number of IP version 4 addresses we are having available to give to our machines for communication purpose. Because on internet, since more number of machines are getting added on a daily basis, the chances of this this IP version 4 addresses uh, getting finished. Okay, it is like what the chances are more. Okay, in the upcoming years, we will be exhausting the full IPv4 addresses, and we will not be having that many number of addresses left to give to our machines, which will be connected to internet. That is the reason steps are taken to save our public IP addresses, because without public IP we cannot communicate. One of the steps which is taken to save your public IP, that is your subnetting. By doing subnetting, we can significantly reduce the number of wasted IP addresses. Another method, that is your NAT. These are the initiatives which has been taken in order to save our addresses. Okay, specifically the public IP. We're not talking about private addresses. Because private address is a free of cost, you can use it, but public address is a unique address, and you have to basically uh, reduce the wastage of your public IP addresses while you give it to your machines. Okay. Just hold on, everyone.
Excuse me, sir.
Okay, everyone. So these are certain terminologies. Okay. What exactly we're seeing over here, that is inside and outside. In this particular network topology, there are certain changes, but what exactly we are doing. Okay. That is your LAN number one. You can see it is having a private address, right? That is 192.168.100.0. This LAN 2, 3, and 4, we are considering it as part of internet. Okay. And this side we are considering as intranet, that is your public. So we are dividing this topology in two sections. One section that is your intranet, and one section is internet. So this part is your internet, which is basically what type of network?
Public network.
Public network.
Public network. And this side will be intranet, which is your private network. So we are going to be doing some modification from the perspective of IP addresses. Since it is public network, so public IP we are giving over here, that is 193. Only just this much change what we are doing. 193. Over here we are doing 194. And over here we're doing 195. Okay. So inside, when we are saying inside simply represents your private network. This is your inside. In net, inside always refers to private. And when we are saying outside, this is your public network. This is the outside. Outside. Outside always refers to internet, that is your public. And inside always is refers to the internet, that is your private. Okay. So inside local and inside global. Okay, you can see that inside local and global. So local means your private address. Okay, this one is considered as a local address. Okay, so inside local means the machine's private IP. This is what exactly we are. And inside global, global means the public public means this IP address will be translated to which public IP. This is what we consider as global. So when we are talking about inside local, always it refers to the private address, what we use on our machine. And when it comes to inside global, that is the public IP via which this private IP will be translated. For example, if we say that 192.168.100.2, this address, this is your laptop one address. This address is considered as inside local. Inside local. And this address will be translated to the public IP address. So let's say that it is 193.168.100, okay, or 101.10. Now, this address is considered as a inside global. Inside global. What exactly we are doing is we are translating this particular inside local IP with this inside global IP, so that like what our machines can communicate on internet. So whichever IP address is local IP address, always it is referring to the private IP address what your machine is using. And when we are saying inside global IP, it is simply indicating that you are using a private IP to translate your private address. Okay. Inside global always refers to the public IP. So when you send your informations, then your information is getting translated from this IP to this IP and it is delivered to internet. When information, that is your reply, is coming in, this is when it is coming in using this address. Again, it is getting translated to this address and it is delivered to the machine. This is the private IP, public to private IP translation. So outside local, outside is referring from the perspective of destination always. Okay. This is your source. So when you send anything from here to here, you are the source and this is your destination. If the destination machine is also performing NAT, let's say that this server also is performing NAT. Okay, or in the number 4 also we have NAT going on. So whatever private address these servers are using, that becomes outside local IP. and whatever public IP they are using to translate their private IP addresses, that is their outside global IP. So from the sources perspective, these are basically outside local and outside global. Okay, because when we are seeing this LAN number 4 from LAN number 1, at the time destination is this server over here, and this server IP address, okay, whatever private IP they're using, that is their outside local IP from the sources perspective, and whatever private IP their public IP they're using to translate their private address, that is their outside global IP. Okay, so inside and outside always is there from the sources perspective, from the destination perspective, from the private network perspective, from the public network perspective, always is it. So three types of NATs exist, everyone. Number one is a static, number two dynamic, and number three is a plant. As the name suggests, static, it means manual. You do manual NAT. You do manual NAT. And manual NAT simply indicates that every single public private IP and public IP every single private IP to public IP, this translation you have to do manually. This entire thing you have to do manually. It means if I have 10 machines, for which I want to do NAT, then I need 10 lines of translation. Ten lines of translation means 10 lines of private to public IP I basically need. So every single 10 machines private IP, I need to define to which public IP it needs to be translated. So since it is like a manual, it consumes time because time is the main factor of it. Every single thing we are doing it manually. So if I am having 10 machines, then 10 lines I have to write translation. If I have 100 machines, then for 100 machines I have to write 100 lines. And when the number of machines are getting increased, this is when exactly the translation also is getting increased. Okay, and since we are doing manually, every single of this private to public translation takes time. And that is the reason we are having this dynamic NAT concept. Basically, it uses ACL, the access control list. ACL we are using in NAT. Why we are using ACL? Because we want to match the private address for translation. Because one of the objectives of your ACL is to match the traffic. Yesterday we basically have seen how we are matching the traffic using the wildcard bits. So matching the traffic always is done using SEL. And this SEL concept, we are using it over here in order to match those private addresses which our machines they're using in our LANs, that is in private network. We have to we have to identify that which particular addresses needs to be translated, which machine's IP needs to be translated to a public IP. We are just matching that. Okay, so dynamically this particular matching is done. So, but for that you need to configure your SEL. So main purpose of using SEL is to identify those number of machines whose private IP it needs to be translated to a public IP. Now, another thing, what exactly we use along with SEL is a net pool. So net pool is nothing but a range of public IPs. So you can see this net pool over here. Okay. So in dynamic net, this pool and SEL always is used. Okay, so pool is all about range of public IPs because we need public IP in order to translate our private addresses. So this pool is defining a range of public IPs, which basically looks like this from 200.0.0.1 to 200.0.0.10. We have 10 IPs. So 10 public IPs. 10 public IPs. So with 10 public IPs, we can translate 10 private addresses. But since these are public IPs, we have to purchase it from our ISPs. So this range is dynamically used. Okay, it is dynamically used. You don't have to define manually your private to public translation because it is used dynamically to give like what public IPs to the address which exactly we want to translate. So this range always is required, okay, in dynamic net. SEL and net pool always is required. SEL is for matching those addresses which we want to translate, and pool is created from the public IP address range in order to translate those private addresses which is being matched by the SEL in your router. And when all these things happens, okay, your machines can communicate from your private network to public network without any problem. But in both these cases, in static and dynamic net, always the translation is performed in this ratio. That is 1:1 ratio. This one simply indicates that for translating one private IP, for translating one private IP, you need one public IP. You need one public IP. So for translating one private IP, you need one public IP. So in our case, if I am having 10 private IPs, so 10 machines are there. So to translate 10 private IPs, we need 10 public IPs. Yes or no?
Yes, sir.
So no matter how many number of machines you are having, that many number of private IP and public IP translation needs to be performed. Okay, so this is coming as a similarity. If anyone is asking you, but tell me the similarity between your dynamic net and static net, this is coming as a similarity. That in both cases, we need the ratio of doing translation between private to public IP, that is 1:1. So Why exactly this tool is not that popular? Why it is not flexible? The thing is, since we are using 1:1 ratio of doing translation, if I have 10 machines, if I'm having 10 machines, then I need 10 IPs. That is, 10 public IPs are required. That is okay because your ISP can give you 10 public IPs. Imagine a company who is having a network which is set up with thousands of machines. In their network, thousands of machines. So for 1,000 machines, we need how many public IPs? 1,000. If we are going with 1:1 ratio of doing translation, then for 1,000 machines we need 1,000 public IPs. Now here comes the problem, everyone, because 10 public IPs your ISP can provide. Okay, 10 public IPs, it doesn't matter. But 1,000 public IPs, your ISP, like what, will not be able to provide you. Okay. The number one reason is public IPs are very limited in numbers. We don't have so many number of public IPs left, okay, to give to machines for communications on internet. Because day by day, the number of machines, they are increasing on internet. And every machine wants a public IP to communicate. If we see our population in India, we are having around 1.3 billion. Okay, 1.3 billion people right now are living in India. Out of 1.3 billion, if I am considering just 60 to 70%, 60 to 70% people are using their smartphones. You can imagine that every single smartphone requires an IP address to access 4G internet. Every single phone out of the 60 to 70% population of India, they are basically using on a minimum basis, one smartphone they're using minimum. Some is using two smartphones. Even we are having multiple SIMs are there in one smartphone. Dual SIM smartphone is there. So two SIMs means what? Two network connection. And two network connection means what? Two IP address is coming over here into your smartphone. So every single of these like what devices, they are using public IPs to communicate. If you look into India's population, day by day, population is growing. Day by day, devices are also growing because people are purchasing like what these smartphones, the tablets, laptop, desktops, all these machines, they are purchasing it. And this is when exactly the scarcity, the exhaustion of our public IPs are coming because we have a limited number of IPv4 addresses. It is not like that you have infinite or unlimited number of public IPs. So if your ISP is not giving you 1,000 public IPs to translate your 1,000 machines private address, then what exactly you can do? This is what you can do. Port address translation. Port address translation or PAT is basically designed to translate all your private address, all your private IPs using just how many IPs for public?
One.
One IP.
One IP. Only one IP against all. All is to one. So no matter how many number of machines you are having, whether you have 10 number of machines, whether you have 100 number of private IPs, whether you have 1,000 public IPs, whether you have 10,000 public IP, private IPs, all these number of IP address, it can be translated using just one public IP. This is what exactly is coming over here as an advantage. Okay, you can see how we are saving, because the main idea is to save our private addresses. Sorry, save our public addresses. Save public IPs. Okay, and PAT is a nice example, because if we are not using PAT, then for 10 private IPs we need 10 public IPs. For 100 we need 100 public IPs. For 1,000 we need 1,000. But right now you can see that how you are saving your addresses by translating all these machines IP address with just one public IP. So this is what we are calling as all is to one. It is also having another name. It's called NAT. This port address translation, it basically uses this port number range to perform the NAT translation of one. Port address translation is a type of NAT. It is not separate concept. It is coming within the NAT type, remember. Some says that NAT is different, PAT is different. Because this one stands for network address translation, this one stands for port address translation. But this is not actually the fact. The fact is NAT is having types, and this PAT is coming as a type of NAT. Okay, so PAT is not different from NAT. It is a type of NAT. Okay. So this port number range always is used. These are coming from our TCP UDP port number range. Remember, all of you, the TCP UDP port number range. Total, how many port numbers we have in TCP UDP?
How many?
How many port numbers we have?
So 60,535.
65536.
6. 1.
Because from 0
0
to
also.
65535, we have the range, right? Correct? And this
Yes, sir.
particular range,
Yes, sir. Yes, sir.
in this range, we have certain port numbers are reserved. Remember?
Yes, sir.
0 to 1023. This port
Okay,
numbers are
okay.
reserved for what purpose? Everyone has forgotten. You guys have forgotten. We discussed it in the transport layer of OSI model. Remember this?
Yes, sir.
0 to 1023. These are basically port numbers reserved for
Protocol and
protocols or services. Then from 1024 to 49,151, it is reserved for companies who build softwares. So for software organizations, it is reserved. And from 49,152 to 65535. This is the port number which is basically reserved for dynamic usage, right? Yes or no?
yes, sir.
Dynamic usage. Basically, from this dynamic range of port numbers only, the port address translation uses, okay, the port number for doing translation from this range. Okay, so automatically all these private addresses, it is getting translated using a private, using a public IP, and this is the port number range what exactly is being used for doing the translation. Now, every single net router, they are maintaining a net table, and this net table contains your private to public IP address mapping. Mapping means which private IP getting translated to which public IP, and vice versa. And you can check the net table in the router by using this command. There is a verification command, show IP net translation, which you can use to basically check the private to public, public to private IP mapping. Okay, this is what we call mapping. So we are having a little bit change in our topology, as you can see. What exactly we are going to be doing is this. We will configure this LAN 2, 3, and 4 in public network, and here we are going to be running RIP. Okay, in LAN 2, 3, and 4. So LAN number 1 should not use any routing protocol. So we don't run any protocol. Okay, so no RIP configuration. We do only number 1. Our routing always it is starting from LAN 2 and it goes all the way to LAN 4. Okay. So what exactly you will be doing that once you configure RIP, okay, you will be sending communication, okay, or you will do communication from router from gateway 1 to gateway 2. This to this LAN, making sure that you have full connectivity between LAN 2, 3, and LAN 4. So full connectivity should be there between all these LANs. This is the reason we are configuring it into LAN 2, 3, and 4. And we don't configure RIP in LAN number 1. Now, it can be any routing you can do. You can do EIGRP, you can do OSPF, whatever. But make sure that LAN number 1 is completely isolated from LAN number 2, 3, and 4. Okay. No routers like router 1 or gateway 2 should know anything about LAN because this is private right now. This is your private network. And private network information is not allowed on internet routers. So this is the routing configuration what we need to do. Understood this part?
Yes, sir.
Yes.
Okay. So to do the net configuration, you have to configure your project in this manner. We are dividing this topology in 2 sections. One section containing the private network, another section containing the public network. In the public network, always you should be making communication. So since we have LAN 2, 3, and 4 in the public network, we are simply just running any routing protocol to make sure that we can communicate from LAN 2 to any of these LANs which is available on internet. And machines from these LANs, since they are not allowed to communicate using the private address, we are not configuring any routing for LAN number 1 to our router, which basically isolates LAN number 1 from LAN 2, 3, and 4. Because if we don't route for a certain LAN on our router, then that LAN becomes isolated and no one will be able to communicate from LAN 1 to LAN 2, 3, and 4. Okay, and this is the perfect situation where you basically configure NAT on your router and you do the translation. And once you configure successfully the net translation, then you will see that all these machines, even though they belong to an isolated network in LAN number 1, they are being able to make communication to LAN 2, 3, and 4 on internet. This is what exactly is coming over here as an what I can say, the configuration. Okay, the configuration, what exactly you do on your net router. So configuration wise, I'm having the full configuration of NAT available. Let me just load the project. This is the NAT full configuration. So these are basic LAMP configurations. Okay, you can see the RIP configuration, interface configurations on gateway 1. Okay, means before configuring NAT, what are basically are the configurations you have to do? I have basically written it over here. Okay, router 1 configuration, gateway 2 configuration. Okay, so all these configurations you were doing it before you configure NAT on your gateway 1 router. So from this section, we have the NAT configuration starts on gateway 1. First of all, we are doing static NAT configuration. Then we are doing dynamic NAT configuration. Then we are doing PAT configuration. So regardless of whichever type of configuration you are doing, whether static or dynamic or PAT, you can see that in every single of this type of NATs, this particular step is similar. Can you see this?
Yes, sir.
It's similar, right? This is your
Yes, sir.
inside and outside. Okay, you can see that in dynamic net also we are configuring the same thing. And similarly, in PAT also, you can see that we're doing the same thing. This thing doesn't change, right? Now, why we need to configure this? Because it is important for your net router to understand that which particular port belongs to your intranet, which port belongs to intranet, and which port belongs to internet. Okay, which port belongs to intranet and which port belongs to internet? This is what exactly you have to tell your router. Okay, and the way we tell our router that this port belongs to intranet or private network or public network is we use this inside and outside term. So IP net inside and outside always is required. If you don't configure this particular section on your net router, then your net router never performs out like nothing. Okay, this NAT is never performed. So coming to the static NAT configuration, everyone, you can see that we are using this IP NAT inside source command. You can see that everywhere this command is same. Over here also can you see the same command in dynamic NAT also. IP NAT inside source. And over here also IP NAT inside source. Okay, this is the way by which we configure NAT. IP NAT inside source, because always we are doing our private network translation. So what we are saying is we are defining what type of NAT we want to do on this gateway 1 router. So the type of the NAT is static NAT. This is your inside local IP. That is your private address inside local. And this one is your inside local. inside global. Okay. Now, from the IP address perspective, it doesn't look like inside global address because it's a private address range. But if I change it to 193, then it becomes your public IP. So 193.168.101.3, 193.168.101.4. Basically, we are taking IP address from this range, LAN number 2. We are assuming that this particular site is the ISP, and ISP is having this network. So already we are using 101 and 102 over here. So from 103 to 101.3 to 101.54, we have all of our addresses available, which we are using to do the translation of our private address. So simply we are configuring it in this manner. So these two machines, private address are getting translated to using this two public IPs. If I have more number of machines, I have to write these lines that many number of times. If I have 10 machines, means 10 lines I have to write like this. And basically it consumes time. And that is the reason we are going for the dynamic net. If I have 500 number of machines, then 500 lines I have to write it. Okay. So in dynamic net, always we are using SEO. So dynamic net is all about SQL configuration and net pool configuration. Net pool. Okay. So SEL and net pool, these are the two things. So SEL we are creating over here with this particular section. This is the section which is identifying the network, what exactly belongs to private. So this is your LAN number 1 network, which is we are considering as private. And similarly, this is your wildcard bits, what we are using 0.0.0.0.255 to match the 192.168.100.0. And after that, we are creating this pool, which is containing a range. So the command is IPNet pool. The name of the pool is the name, pool name. This is the name of the pool. Then we have the start range over here. Start range. And we have the end range. So this is the end range. Start range and the end range. Okay. So this start range and end range subnet mask we are mentioning it over here. That is your class C subnet mask 255.255.255.0. So once you define that, then you say IPNet is a source list command. This is always used to refer the access name, which is mynet. And pool command we are using to refer those IP address range pools what we have defined in the public IP pool. So the range is from here to here. So this range we are referring over here. So once you have done this particular command, this is when you will see that you are being able to communicate machines, okay, on internet from your private network. But in both the cases, we need the number of private IP address translation, okay, that many number of public IP addresses. That is your 1:1 ratio, okay, which is not good. And that is the reason we are going for the turning this port address translation. And port address translation is all about SQL configuration what already you have done over here in your dynamic net. So you can see that this up to here, in fact, if you compare the configuration, this is your dynamic net configuration. It is exactly the same configuration what you were doing in fact as well. The change is over here. We don't need a pool in dynamic in fact. Okay, you don't need a pool. Instead, you need only one port or only one IP address, and that IP address also we don't have to purchase it because the public IP. What we need to do this translation, it is already there in the on the interface of gateway 1, which is connected via physical/1. Can you see this one? Can you see this port? These are all ISP, right? All these routers, router 1, gateway 2, all these are ISP routers. And when you take a connection, internal connection from your ISP, that is when you are also getting one IP, right, on this port. Yes or not?
Yes, sir.
So this public IP, we know that public IP is chargeable, we have to purchase it. But in this case, to do the translation of your private machines, you don't have to purchase any additional public IPs. The IP what you have got from your ISP on your interface on the router. This is the IP address what you can use to do all these address translations. This is coming as a benefit, as an advantage to use port address translation because we don't have to purchase any public IP at all. Because the translation, what exactly is being done, it is basically done based on port numbers, what we have the range from 0 to 65535. And this is the overload command, which activates PAT, port-based translation on the router. If you don't give this overload command, this PAT is not activated. Remember this. If you use overload command, then port-based translation, it will be starting on the router. Okay, it will happen. So configuration wise, lots of similarities. If you see this NAT configuration up to here, you can see it is the same. Over here also we have. The only thing which is different is this pool is not required because in fact we are not using multiple public IPs to do translation. Instead, we are using only one public IP, and that IP address also we don't have to purchase because it is already there on the router which is connected to internet by its interface FS0/1. And lastly, with the overload command, we are activating port-based translation on the router. Understood?
Yes, sir.
Yes, sir.
So what I want all of you to do right now is take screenshot of all these configurations and Bhaskar.
Yes, sir.
Bhaskar is there.
Yes, sir.
You will be doing these 3 types of NAT configuration one by one. You will first do static NAT configuration. Okay. Then you will do dynamic NAT configuration. You will delete the static configuration and you will do dynamic NAT. To delete NAT, static NAT, you simply say no. Understood?
Okay, sir.
If you want to delete the static NAT, then you simply no, say no over here. If you want to delete the dynamic NAT configuration, then you can delete dynamic NAT configuration directly from here. Just say no, I cannot inside source list, it will delete that. And similarly, if you want to delete a PAT configuration, then say no, like this. So you will do all these configurations, okay, on gateway 1. But before that, these are the setup, what exactly you need to do on all these routers. From the very scratch, you will do it. Understood?
Okay, sir.
So simply take the screenshots, everyone, all of you. Taken
Yes,
Yes,
sir.
sir.
the router 1, this is the router 1 gateway 2 configuration.
The scroll up slightly.
Finished?
Yeah, okay, sir.
Then router 1, gateway 1, gateway 2 configuration. Taken. Then gateway 2 and net configuration. Then net configuration. Taken.
Yes, sir.
Then this is your dynamic net and pat. This is the last section.
Done, sir.
Finished, right? And always use this command to do your verification, show IP net translation. This is a verification command. Now, Bhaskar,
Yes, sir.
share your screen now and do this from the very scratch. This reload your router, okay?
Yes, sir.
Start your router by deleting the configurations.
Okay, sir.
Gone.
Sorry. Okay.
Erase the configuration first, then restart your router.
Okay, sir. So this will be our part of this whole thing. Sorry. So this is your public network, or I can say internet as well. Click on the, and this is our private network or internet. So here I will assign the public IP address. Public IP address range I am selecting. So it will be 1968. Okay. Okay. So first you have to do this configuration. Okay. Sorry. It's coming. Okay. Signing 93. So now first I will configure my interface onto the routers. So I will go over here and enable on 15. I will just change the host name, which is gateway 1. Then I will do interface at a 0/0 IP address 192.168.100.1 55.55.55.0. No shutdown. State has been changed to up. Now I will exit from here. Interface a 0/1. Same thing. IP address 193. One I will assign. Sorry. This I have done. Then I will do most down. That's it. So should I configure RIP at present only, or should I first change the state of all the routers?
You can configure any routing protocol like Hsrp, OSPF, RIP. For simplicity purpose, you can configure RIP.
Yeah. Router RIP.
First, you configure. Do this step by step. Okay, Bhaskar.
Okay. First,
you configure IP addresses. Then you basically do the ping test. Okay, make sure that you have connectivity. And after that, you configure routing. Then try to ping from LAN 2 to LAN 4. Make sure that you have connectivity. And after that, do the configuration of that. Okay, step by step.
okay, sir. So now, okay, I will do exit. I know. Then I will do config here. Then again the interface. Sorry, host name is already interface 1. So I will do interface. Sorry, this is already done. Sorry, now I'm moving to router 1. So I will okay, turning it on. So okay, 0/1. Shut down.
Bhaskar,
Yes.
Bhaskar,
Yes, sir. हाँ बोल भाई मुकुल. Yes.
193.168.10.1.2 ना
1.2.
1.2
101.1 आएगा. Sorry, 101.2.
Oh, sorry. 1 minute. So should I do go to interface? One second.
Yes,
yes.
interface.
Okay, 0/1 and not 1 dot. Correct.
Yes.
Fine.
No shutdown.
Hmm?
No shutdown.
No shutdown.
So it's already up now. So
For confirmation.
okay, fine. And then
Exit.
that's it.
Interface 0, 0.
1 minute. Besides this change already, right?
Changing already.
Yes. So I will now switch to interface.
0, 0.
Let's say /0 and same thing, IP address 93.168.102.1 55.55.0.
No shutdown.
No shutdown. Okay, exit interface. Okay, this is done. So now I have to jump to gateway 2, turn it on. CLI. Okay,
0, 0.
/0 IP address 292.168.2.2. 55.55.0. Should I change to up? /1 IP address 193.168.1.3.2 55.55.0. No shutdown. Correct.
Yes.
So now this is done. So now we'll verify whether we are able to communicate between these routers, gateway 1 to router 1 and router 1 to gateway 2. So okay. Set 192.168.193.168. From router 1 I am verifying gateway 1, sorry. So it will be 1.1.2. Fine, it is happening.
Reply.
Yeah. So from here also it will happen. Exit in 92.168.102.2. Correct. At the same time, we should be able to communicate with the 101 also. Yes, correct.
Yes.
So this one. So now this is a private network. So now from this device, we won't be able to communicate to these devices, correct?
Yes.
But this is our private. So no, this we can able to, because they will be from here to here we will be able to, because they will be exposed on over the internet. Think. No. Okay, right now we are not configured the routing, no? So it won't work.
Yes.
Correct. 190. Let me verify once. 191. Not 3.2. Yes, because we not configured the routing. So
Unreachable.
we'll go over here.
सर्वर के आईपी भी चेंज नहीं किए ना,
Which one?
सर्वर साइप 193.
Okay. Yes. Over here. Configuration. 93.
Now check.
No, now it won't work, na? Because on our routers still the routing protocol is not configured.
Yes.
So you have to configure the RIP or any kind of protocol. So we'll go with RIP. And T already done. So it is router RIP, correct?
Right.
Then version you have to select, correct?
Version 2.
Then
2.
directly we have to enter, no? I'm not wrong.
Yes. Space 2. Version 1.
Version space 2. Then you have to set the network, correct?
Network.
So I am gateway 1.
10.
So we have
LAN
to do
1
network. We have to
or LAN 2. 192.168.
93 आएगा.
193.168.101.1.
0 आएगा.
00. Network ID.
Okay, network we are configuring that.
Yes.
But 1 minute.
No,
we
actually,
have to
RIP.
LAN 1.
1 minute, just 1 second. See, correct. Okay. Correct. This is fine now. This is done. So now we can exit. No auto submit. Correct.
Yes.
No auto.
Hyphen.
Summary. Exit. Now I can exit. Correct.
Yes.
So if I want to check from here, so show IP route should show some. Yeah. Correct, no? So
Yes.
Connected.
1 minute. So it should come R, no? No entry has come with the R over here. It is also showing the connected network, no?
Yes, direct connected.
One R, huh?
92 enter
One.
first one.
No, I'm saying just like when we are checking show IP route. So here it is showing only the connected network information, correct?
Yes.
But we have configured the RIP protocol. Correct?
LAN 1 or
So one entry for RIP also should come, na?
LAN 1 or LAN 2, na?
Version 2. This is my LAN. Yeah, this is LAN 2.
LAN 1 और LAN 2 दोनों भी कनेक्ट करना पड़ेगा ना?
No, LAN 1 we don't want to connect right now because then our network address transmission won't work.
Yes.
We have to make it disconnect. Okay, one minute. Let's first configure this one, router one, and we will see. So I will go here, config. Okay. Again, host name has not changed. Okay. So we will do same thing, router
RIP.
RIP. I am configuring to router node.
Version
Version 2. Version 2.
Then same thing, network 193.168.101 dot.
0.
Sorry. Network and correct.
0. Yes.
And this will be 102.0. Correct. Now
No auto summary.
so summary. Correct. Exit.
Yes.
Correct. Now
Yes.
need to exit from here. And do show the verification command from
101 or 102.
1 second now. This verification command. Okay. Let's see. So now I go to gateway 2, correct? In gateway 2 also we have to configure. So host name, gateway, gateway 2. Okay, and router RIP version 2, and same thing network. Network is 193.168.102.0 to 103.0. Now go to summary, exit. Correct.
Yes. Show करके तो
Now we should let's show IP today. Now we should be able to communicate, na?
Yes.
But now also we won't be able to. If I'm not wrong. We are able to. Okay. We are able to correct. We should be able to. The first time out.
Good.
No, yeah, routing is not happening. Some issue is there.
Router.
1 minute. Create also 92.168. Is unable to. Some problem with the routing. Here our entry should come. Why is not coming? You're getting what I am saying? Because we have configured the RIP protocol now.
Yes.
So RIP entry should come over here. Config router RIP. version 2. It is connected with 1.2.0. Correct. No auto summary exit. Correct, it is. Very confusing. Now it came. Now it came.
Yes, one. Yes, yes.
But now 2 entries have happened. Getting now 2 entries have happened. So how to delete 1 entry? Okay, let's see here. It is configured or not. Here also. Oh, it's taking time.
Yes.
Okay, okay. For finding the path, it is taking time. Okay, okay.
Yeah.
Configured.
Yes, done.
So
Now
now
we
we should be able to communicate. Correct? So it's not able to communicate. It's not doing the translation part. That's why.
Trace RT
I
करके देखो
think.
भास्कर.
Sorry.
Trace RT from server 1
From server 1.
to LAN 1.
Okay.
Trace RT. Trace RT.
RT.
Trace RT.
Yes, root.
Sorry, sorry. I am not getting it.
Trace RT.
Oh, trace RT.
192.168.100.2. 3 तक की जा रही हो.
It will take time. Request timeout.
From LAN 1 से trace RT करके देखो एक बार.
From here to here, we are able to communicate.
नहीं
1 minute. Why? This is the wrong entry. 102.1.3. Okay, okay. I have collected all the information. 102.
Okay, what is the issue?
No, sir.
Can you ping from gateway 1 to both of your servers?
From gateway 1 to. Yes, sir. There. 1 minute.
Ping this server.
Yes, sir.
And this server.
Yes, sir.
Okay. Now ping from this machine to both the servers.
So from here it is not happening.
not happening, right?
Yes, sir.
Yes.
Yes. It should not happen because we have not configured NAT, right?
Okay.
So you have to do static NAT. Do your static NAT configuration on your gateway 1. Now drag this window a little bit on the right side. This port belongs to inside,
That one will be also. Okay.
and that one is outside.
Okay.
So you configure first. Go to the interface of a 0/0 and say IP NAT inside.
Mukul,
Yes.
brother, can you tell what is the command for this?
I am on the mobile. Then after that, I can't see the screen. Then
Okay. Okay.
someone else.
IP NAT inside. Inside. Press enter. Then configure this port.
Interface. Exit.
Exit. Then interface F0/1. IP NAT outside.
Sir.
Exit. Then you say IP NAT inside source static. You give this machine IP. What is this machine IP?
192.168.100.4.
Space. Take one IP from this network.
Okay. 193.1.1 only I will take.
193.168.101.3.
3 I will take.
Press enter.
Yes.
Now exit. Now give show IP NAT translation. Check your NAT table.
NAT.
NAT table.
IP NAT. NAT NAT.
NET, no?
AA.
Sorry.
NAT.
Network address translation. Yes. Yes, sir. It is.
Yes,
Back
it is
to-
there, right?
Yes, sir. Yes, sir.
So this is, can you see this local? This is your
Yes,
private
sir,
address.
Yes.
Yes, sir.
And can you see the global? That is your public.
Public address. Yes.
Right. Now you go to this machine and send a ping.
Working.
It's working.
Yes, sir.
Okay. Now go to your NAT router and give that verification command again. Enlarge this window.
The same.
Yes, the same command. Give it. Can you see the translation right now, which is happening?
Inside local 103.
This is your address, 100.4, right?
Not 4. Yes, sir.
It is getting translated to 101.3, right?
Yes, sir.
And it is going to which destination?
Okay. 103.193. Yes, this one only.
Hmm.
193.168.103.3.
Now, this what you were seeing, these things, right?
Yes,
These are
sir.
basically what? Port numbers.
Okay.
Okay. These are port numbers, what exactly is used. But in static net, dynamic net, we don't use port numbers. But when our information, that is our packet, when our packet is going from one machine to another machine, this is the format in which our IP address is going. It is called a socket. Okay, an IP address separated by column with a port number. This is what exactly we call it as socket. This information is there in your packet. Okay, and this is what you are seeing over here in this format. Okay, this is your IP address. This is your port number, and this is the column in between. This is what the entire thing is called a socket. We call it socket information. But if you are getting the idea, right, that how exactly these addresses are getting translated.
Yes,
Can
sir.
you see the protocol ICMP is coming
ICMP, yes, sir.
because we did the ping, right?
Income, yes, sir.
So do this dynamic net and pad configuration. Let me know tomorrow if
Yes,
you
sir.
have okay any issues. Okay, all of you do the Divinity projects.
Sir, one doubt, sir.
Tell me.
Which one will be the outside local and which one will be the outside global, sir?
Outside is destination on internet. Okay. Suppose on internet there is some LAN which is also doing that. So for us, internet is outside, right?
Yes.
Because we belong to inside. Correct or not?
Yes, sir.
You will be doing your NAT from your network perspective, right?
Yes.
That is from your inside. Okay. Is there inside? So you are the network administrator of your network. You are not the network administrator of the destination network, right?
Yes.
So whenever you will do your netting, 99% you are doing your netting from inside perspective. Okay.
Yes.
Not from outside perspective. Outside is basically destination. If the destination network is also doing NAT, then their private IP is considered outside local, and their public IP is considered outside global. That's it. Bhaskar, you can close your share now.
Yes, sir.
Sir, I want yesterday class screenshots, sir.
Yesterday's session screenshot you want.
So I'm not attending yesterday's class, sir.
Why?
I'm outside, so I'm not available.
Okay. Just hold on. Let me load that. This is the access list.
Okay, sir.
Take the configuration. This is what we have done yesterday. Taken.
Yes, sir.
Take
Taken, sir.
this. This is the last section.
Yeah. Okay, thank you, sir.
Okay, and this is your SQL notes. Take it.
Okay.
We also discussed DSCP, right, everyone?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this is your DHCP configuration. Take it. Taken.
Yes, sir.
Yes, sir.
This part.
Yeah, done, sir.
Okay. So that will be the access list. This access NAT. Okay, simply just do the projects. Okay, when we're doing the projects at the time, you basically get to know all these things. Just hold on, let me take the screenshots. Okay, everyone. So that will be it. I will see you guys in the next session. Okay, and in the next session, we'll be seeing about device management. Okay, how exactly we can do that, and similarly Hsrp. This concept is also pending. So do this dynamic net and pet configuration, and make sure that you have it working. Okay. If any issues are there, okay, if you face any problem, then let me know about it in the next session. Okay. Bye and take
Okay,
care,
sir.
everyone.
Bye. Thank you, sir.
Bye,
Thank
sir.
you.
Thank you, sir.